Hello and welcome to this SlimDevOps Live episode 42. This was originally streamed live on twitch.tv/SlimDevOps on the 5th of May. If you're watching this after the fact on YouTube, head over to twitch.tv/SlimDevOps so you can join our streams interactively and ask questions as we go. Hello John, how are you?
Hey Martin, how are you?
I'm very well. It's lovely to have you back. It's been a while since we've done one of these together.
I know, sadly. I wish there was more.
So, for those of you in chat who haven't met John before, John is the CEO of Slim.AI.
Hey everyone.
So we've got a few people. I'll just welcome back some friends and colleagues. We've got Primoz, who's on our engineering team. He's in chat with us today. So hello, Primoz. We have Ashish, I think I'm pronouncing that correctly. Thanks very much for joining the stream today. And Diddledan, hello, welcome back, Diddledan. How you doing? Oh, and Aisha as well, one of our colleagues, Aisha. Hello, Aisha. Welcome back. So, John, what have you been up to recently?
Quite a bit. So Dockercon is next week, and we've been really busy working on some cool tech for Dockercon. We've got a Docker desktop extension that brings the power of Slim's search and analysis and all sorts of features to the local Docker desktop experience. And that's, I think, really good for developers, as it kind of takes all that power we've been building between Docker Slim and our cloud, and it puts it in a place right next to your containers in your Docker environment that you can use to do all sorts of fun stuff that I'm sure we've shared many times through this channel and others. So that's been really busy.
Yeah, we did. We had Evan from the engineering team on a few weeks ago now to do a first look at that Docker desktop extension, because we're part of that partner program. There's probably about a dozen of those that are going to launch.
Sure.
That's all set to happen next week at Dockercon. Yeah, and I've been sort of pulling in the same direction, because the other thing that Docker Desktop are doing next week is unveiling their Docker Desktop for Linux client. And through the partner program, I have had early access to that. And I've been discussing things with their DevRel team, and I now have a fully furnished desktop client on my Linux workstation. So I now have the benefit of our new extension as well. And we're going to be doing a few. Go on.
We love that Linux is a first-class citizen there with Docker, and certainly we're building there too.
Yeah, absolutely. I mean, for me, it's terrific, because this sort of is the missing piece in the puzzle. You know, when you've got all the great things like Visual Studio Code and Git Kraken and GitHub Desktop, you know, you've got all of this tooling, and then the one piece that's missing, where you don't have desktop parity with the major platforms, was Docker Desktop. So I'm obviously delighted to sort of fill that gap in my sort of, you know, development tool set. But we've got a couple of things happening. There's a lot going on next week, actually. So for those of you who are in the stream, I encourage you to go and sign up for Dockercon. It's free to sign up and participate in that. Evan, who's presented here, has got a great presentation he's giving next week. And we're going to be doing 2 streams here next week to complement what's happening at Dockercon. We've got an interview with Sam from our design team to talk about how we designed our Docker desktop extension, and then we've got another interview later in the week with Joseph, who's one of our tech leads, about how we actually built the actual software and some of the challenges we faced with working with a brand new platform. And then we'll be doing an exclusive Q&A in our Discord server, our community Discord server. So above my head, that's the URL. If you visit there, you'll find links to our Discord, and also, as of today, in the About page for this Twitch stream, you'll find we are replete with some beautiful panels, one of which is details about our Discord server. So you can go and click on the panels there and go directly to our Discord. So we're going to do an exclusive community Q&A in our Discord server next week, so you can quiz our design and engineering team about our Docker desktop extension and us about what it does and what you might want to use it for. So
yeah, we are a platinum sponsor of Dockercon, which is the highest, I guess, precious metal version of a sponsorship, and we have quite a few segments there as part of the curriculum for the Dockercon proceedings. So you can come see other interviews with us, and it's going to be pretty cool. I think great opportunity for developers to check out what we do and understand more about us.
Absolutely. And I think that leads us on to today's discussion, because you've got a topic that you've been giving a lot of thought to recently, which is sort of the software supply chain and how to better secure it from the perspective of developers. So what's the concept here?
Software supply chain security, kind of the first one is, so what, right? Why do we care? And I think there's been a lot of focus on this lately. There were a few serious attacks, kind of very highly publicized, breaches that were caused by software supply chain focused exploits. And basically, every company that consumes open source software and free software, which is every company,
right,
and every business and every developer, I think today it's a fair statement to say, as we consume this software, and use it in our own software, you end up in this kind of like perpetual supplier consumer relationship. You consume some software, you make some new software, you send it on down the line, somebody else consumes it, and so on. And because of the scale of the free and open source software world today and the availability and consumption of it, you've got this massive supply chain of these producers and consumers, right? That underpin everything today with digitization and software. Now, if you give that a moment of thought and you think about the dependencies and the amount of software we consume, that supply chain is massive. It's got, if you look I've got a piece of software, let me look backwards into the supply chain and think about that. You've got all the packages, all the shrink wrap software, all the software consumed as binaries, etc. Those are all published and created by other people and built by a myriad systems, everything from someone's laptop to CI/CD pipelines and the like. So this is a massive machine of software building and publishing, and a massive network of individuals and groups of individuals that are busy writing this code. And one of our key advisors, Trevor Rosen from GitHub, he's a member of our advisory board and a friend of ours, likes to say, and I gained this kind of interesting perspective from him. When it comes to software use, free open source use, he likens it to eating food off the ground, the current practices. I mean, you'd never eat food off the ground. I think my dog does. He's right around the corner. He eats food off the ground, but he's kind of built for it. But it's not that far fetched. And food analogies, I've come to appreciate after talking to Trevor, are great kind of fodder for talking, or I guess a food supply chain is great fodder for talking about software supply chain. So the first thing is, his claim is we're all eating food off the ground. Now, at first it doesn't sound so great, but then you give it a second of thought and you're like, what is the software consumption version of eating food off the ground? Well, you wouldn't eat food you found on the ground laying around. So do you trust the place you got it is a cool question, right? Like, okay, it's on the ground, and you ask all kinds of questions like, who put it there? And then you ask questions like, what's in that food?
What's
could have
it made
poison
of?
in it. Right, what's it made of? And I think, when you think about eating food, you should probably, and there's lots of reasons, health benefits and such, to know what's in the food you're eating, right? And then you kind of want to know who put it there. And in the world of food, right, especially in the United States, we have something called the Food and Drug Administration, which kind of has this halo of oversight over like the food you eat. At least you know that it's packaged, the package looks good, you got food data on the side, it comes from a place that you could probably look up some information about. If not, it's got some like pretty official looking like information about it, or it came from the farm down the street. You get it, right? So so we usually don't eat anything we can't tell where it came from. We usually, or don't trust where it came from. We usually don't eat things we don't know what's inside it, and there's degrees of goodness. And we usually don't want to eat something where the package was tampered with, or we couldn't tell that it was pretty much the same as it came from the person who made it. Those three concepts, knowing what's inside, understanding and trusting where it came from,
right,
and then knowing that it's got the right ingredients, the minimal good ingredients that you choose. And so, if I was a person that, was really caring about my food, I might worry about how much fat's in there, how much sugar's in there, how much all this is in there, right? And there's degrees of that. But the eating food off the ground, as an analogy for how most folks consume open source software, especially individual developers, is not a bad thing to have in your mind. Okay, so let's think about the software analogy of that. Okay, so where did that, I'm about to use a piece of open source software, right? And maybe I was clicking around for, on Google to find out, like, I need a library that does X, Y, Z. Let me find some code snippets. Let me find that magical Python library that's going to do the trick. You go there. How do you know it's a good place to go and get software? That's
right.
Kind of like, is it on the ground or not? Concept. There's a kind of a seminal thought when it comes to like software consumption. Know the software you're about to use and reuse, right? Know your software is a term we use inside of Slim. I think you're going to comment, Mark.
Yeah, and I think we've got a couple of comments in the chat. One of a couple from Primoz, who's on our team. And the first observation he makes is that, it's important to be clear that free and open source software is not necessarily secure by default.
Boom. Yes.
And that can mean two things. And I think we'll get to the second one a bit later. The first being there are going to be security vulnerabilities in it, and that's something you need to be aware of, has the potential for that. And the other is the provenance of these things.
That's right.
And how that ownership may change over time as well, which I think we'll touch on as an important part of this.
Yeah, so bad actors, and especially sophisticated bad actors, what they'd love to do is make you use software that they published and you didn't know it. Or make you use software where they swapped components, they surreptitiously put their stuff in, and no one in the chain of custody could tell.
Right.
And these are supply chain attacks, and the wonderful part about supply chain attacks is, and to Primoz's point, free and open source software is not secure by default. The degree to which the publishers or even the consumers care to understand the likelihood or the risk of consuming that software with a lens towards, is it securely built and designed? So I can make plenty of opportunities to like make bad software and good software, but there's vulnerabilities or bad coding practices you never know, right?
Right.
And then even more nefarious actors will want to try to put intentionally bad software in there, software that's made to give them control over the future implementation of that software, and that's a like ridiculously scalable attack, right?
Yeah.
I surreptitiously insert some software into a key library. That library, through the wonders of this giant software supply chain, gets packaged up with all sorts of other software, and suddenly I've got great software distribution. I basically have a distribution partner. That's everybody who uses this. And so that goes to the idea of, and I think you were leaning in a little bit on this, Martin, who's in charge of this software? Are they securing it from the composition of the software and from their ability to build software in a way that is immune to insertion attacks? And then are they doing a good job of securing that code? And can I trust them? And first of all, obviously, are they a good actor? Most of the time, I think that's true. But are they doing what they need to do to keep track of it? And I say in any case, the responsibility for making sure the software is secure always relies on the consumer making their choices secure.
Indeed.
And I hope for the future that will extend to producers. And we know there are, the vast majority of producers are well-intended and good actors, good and fair actors. So, but it doesn't mean that there's not an opportunity here for exploitation or even just mistakes or bad practices. And building software is hard, especially with high complexity. And unfortunately, that's the world we live in. It's been good for getting software built and making the digital economy flourish. But this is one of the risks that comes along with it. Yeah.
And Danny, who's in our chat, makes the point that, supply chain exploits are the most vulnerable bit of the software development chain, in their opinion, at the moment. And I think that's a very safe assertion to make there, Danny, because we have
so
seen multiple ways in which that software supply chain has been subverted by, malicious actors. I mean, a hat tip, in creative ways. They're obviously highly motivated because some of these modules that they are able to add code to in a legitimate way, having taken ownership of another module that they add a dependency for, and then backdoor these modules that they've signed up to be the new maintainer for. I mean, it's ingenious, really.
Yeah, one well publicized attack. I won't mention the person that the organization that was sort of targeted, but in the end, the attackers were able to insert malicious code into software that was sold by this one firm. And that software was part of their IT and software management suite that other companies use to control their software and their deployments.
Right.
And so effectively what they did was they got their code into the command posts for massive software deployments and massive system deployments around the world. So they actually were able to exploit the underpinnings of other organizations' control over their IT environments.
Right.
And that's like a really scalable attack because you are effectively exploiting the watcher, the tools that people trust to deploy secure software. It's really at the that really attacks the software management infra. That's a dangerous attack.
Indeed. So we've discussed there the problem definition and the scope and the impact. So you've coined this term the 3 S's. So what are the 3 S's and how are they going to help?
3 S's, just S's, I think, and the alliteration is fun. So we tried to pick some topic that is kind of a kitschy play on the letter S. The 3 S's are slimming, SBOMs, and signing.
Right.
And what really these represent are kind of high-level concepts or tools, or I'd say approaches. I'd say more than they are just an SBOM is just a record, right? Like it's notional, and each of those means something different, but are approaches that a developer can take to do their best part as a consumer and a producer in this massively complex supply chain that lives with all software developers today. So let's first go back to kind of 3 guiding principles that we believe developers can follow to make their software more secure from a supply chain perspective. The first is know your software. Right. And we mean that in the most deep meaning of know your software. Our position is that developers should really understand the packages they use. They should understand to some degree whether they can trust those packages, and they should also understand to the extent which they need those packages. And we know that default configurations for package managers and such will pull all kinds of stuff in to make the development experience super easy for developers, so that they're able to build fast, and we want that, right? But just because, and I know it's super easy with modern frameworks to just say, I'm only going to care about the bits that I use or I interact with. The rest of it's kind of a fuzzy black box that I'll accept, right? I think it's that kind of practice that leads to, in the long run, a malaise about owning the responsibility for what you put in prod, and therein lies some gray area that can be exploited. So the first is know your software, know what you're using, know what you're shipping. The second is only ship to production what you need to run your app. That means don't ship extra packages, don't ship package managers, don't ship extra shells, don't ship helper things, don't ship libraries of any kind that increase your risk surface, increase the vulnerability possibilities, and increase the usability of that container, just in case a bad guy gets in charge of it.
Yeah.
Because every piece of software that lives in a piece of deployed code that isn't necessary is a new thing an attacker can use to stage from that posture. and gives them more ability to interact with and exploit your environment. And so let's take everything out of the shipping code, right down to the last bits that my system needs. And the third one is really make sure that you've done a diligence and have some formality, so that when you consume containers, you understand the authenticity and the provenance of all the decisions and actions and automations that happened upstream from you.
Right.
And there are some cool tools that have been emerging to allow you to do that. And when you ship software downstream, be kind, rewind, do the same.
Yeah.
Put some diligence in what you ship with your software, and what you do to that software along the way to key others in who might consume it, or people in your organization that are about to deploy it, that you've taken diligence, and that indeed what you think you're putting in prod is in fact what gets to prod. And it really completes the chain in verification. So it's, again, I'll reiterate, know what's in your software, only ship to prod what's necessary, and as part of that, ship low risk surface area, and along with that, the least amount of vulnerabilities and exploitable code possible.
Right.
And those are the key tenets that drove the 3 S's. Back to the 3 S's: SBOMs, slimming, SBOMs, and signing. SBOMs is a moniker for know your software, right? It's an SBOM is a digital representation and one that can be used programmatically to guarantee that you know the recipe for your code. Right. By producing SBOMs and by interrogating the software, Slim.AI makes tools that make it, and Docker Slim are tools that make it super easy for you to see inside a container and understand it. With SBOMs and that kind of technology, it's all about having a record and an appreciation and the diligence to be sure you know your software. Slimming, pretty straightforward. It's the part of ship only to production what you need. Slimming is the act of minimizing the operational footprint of code as containers. That's what Slim.AI is built on and based on. We talked a lot about minification and slimming. It's the act and the process of removing as much software as possible from the downstream production image. And signing is this act of really knowing about provenance. It's the literal act of signing and also consuming signatures. And it's this ability to convey the authenticity and provenance and the I'd say that the adherence to the recipe, that a user of your software can be sure that they're actually deploying what you intended for them to deploy as a developer. Those are really the kind of why, what, and a bit of explanation among the 3 S's.
Yeah, so there's a couple of comments from Promotion Danny here. That they were both identifying different aspects of that sort of broad impact of pulling in a module in any language these days. The tendrils go out quite far and wide. Right. And Danny made a very interesting observation, actually. So they were saying, I think we've gone full circle back to the closed source monolithic waterfall days. Everything was about reducing the attack surface. Then we came to open source agile continuous delivery and seem to have forgotten about reducing the attack surface. And we're rediscovering some of those old tenets.
I couldn't agree more. It's interesting, right? I think when the software universe was much smaller and the complexity of software was much lower, and when developers probably developed as much software as they consumed, minus the operating system, but it was a much smaller universe. And because we wrote a lot of the software, we had to know about the deep details of it all. We pretty much knew our software, right? Now, the internet, modern organizations, software, universe has really exploded. It's great. We go faster. We build big things. It's amazing, right? But now it's like, okay, all of that frenzy, all of that chaos and entropy have caused a problem that we have to circle back on. Now, the critical reality here is, in order to know your software, you have to have an autonomous, really good system that scales, right? Because no developer can literally know all the software. Right. So we have to rely on tools, and great developer tools, I think, are imperative here. Like tools that don't just show you what the software is as a developer, they give you insight about what to look at. It's like I've got this massive complexity. Where should I look? What matters most? And how do I manage that? Now, slimming has a really interesting effect here, right? Because to Danny's point, the supply chain, as we remove packages, we prune these giant swaths from the entire chain out of our care about list, right? If I take a node package out, I take out all the concern of the upstream contributors to all the dependencies and the code. So it reduces my burden. So not shipping stuff to anything I don't need to prod has this great effect of lowering the effective risk surface in prod. But it also reduces my effort to manage my supply chain, right? That's a key thing here, right? Because even if you sign something, that doesn't answer the question whether you need it or not. It just says that I can trust that it's what the author intended.
Yeah.
But I'll paint a doomsday scenario that's like scares the crap out of me every time I think about it. Like if it's not going to be long, I predict, before we see an attack that looks like a sleeper cell who's been building software that we trust for 10 years, gets it published everywhere, and then suddenly they flip the switch, and now that code is a weapon. And we didn't know to not trust them because they did all the provenance stuff. They did all the code stuff. They looked and acted like a very good actor. But and recently we've seen a bunch of, I'd call them disgruntled. We've seen a few of these disgruntled software producers who have literally bricked their own software, right? That's sort of a less malicious version of my Michael Crichton book about software supply chains. So I think we need to be able to give developers great tools that allow them to understand their software, control it, and do it at scale. And that's the hard problem today.
Yeah, so there's a couple of interesting points there, and I see Tommy's made a good observation as well, and I'll get to that in just a moment, Tommy. Thank you for your comments. So Aisha is also in the chat here, and last year Aisha produced an excellent report looking at just over 100 of the most popular container images on Docker Hub, and did some deep analysis on that. And you're talking about you use a module in your application because you require it. But there's also another problem that I found fascinating that Aisha identified, which is increasingly we see developer tooling actually going into production container images, because those production images are also the images that are used for iterative and fast development. So even if you produce your software bill of materials and you've got all of this stuff in there, well, you've got a whole bunch of stuff that you absolutely do not require, in addition to things that you may or may not require and you don't know it. So what I find interesting about the slimming process is this. We talked about like shells and interpreters and tooling. We're increasingly seeing island hopping happening within containers, leaving developer tooling and configuration management tools and things like that in container images are now being exploited to actually use, maybe, some buffer overflow in your application, which can happen sometimes, to then access this tooling and then reconfigure your Kubernetes cluster and launch a deeper attack on your infrastructure. And this is where slimming really excels, because when it analyzes your application, well, none of that stuff is needed. So it all just gets jettisoned from the optimized container image. So there's a second order sort of security hardening that's happening there. And that's even before we get to things like the auto-generated app armor and seccomp profiles that come along in the mix as well, which is something we need to probably do a deep dive on here at some point.
More about that. That's a good one. Yeah, that's a really good one. Yeah, I think there's a lot of relevant concepts there, Martin. First of which is, we want developers to go fast building things in the pre-production realm. And so we want them to use their tools, and we want them to embrace them and have a stack that they know they can build code fast and secure and do it in a low friction way. And that is sort of the antithesis of of this kind of security by hardening. And if you harden too early, what you do is you ruin the ability of the developer to go fast. So this kind of premature security optimizations, when they're pushed from the right to the left, landing on a developer's desk pretty much can make them have a bad time to develop. So what you'd like to do is have developers use whatever they want, right? And then have a way stop along the route to production where you can automatically, in the appropriate context, remove all of these ancillary toolings and unneeded packages that were there because the developer wanted to use them to go fast, but aren't needed for production to avoid the problems you have. And that's the idea behind Slim.AI and Docker Slim's autonomous kind of minification. It's let the developers use what they want, containers with the kitchen sink in them. But then when we change that tag on that container to be production grade tagging, that we know we need to run automated minification so that only the code we need ships to prod. Along with that bathwater goes vulnerabilities and all of these potential staging exploit opportunities, and of course smaller containers are better for other reasons. They spin up faster, they take up less space on wherever they're stored, and they move around the internet faster as well, so that your services are a bit more responsive and even more resilient.
And so Tommy makes a really good point, and they say the issue is always where the trust lies. Can I trust what my distributions package maintainers do? And by distributions there, I assume you're talking about like the Linux vendors. What did they let slip? How outdated are the packages? Well, this is very true because, if you look at the major Linux vendors' archives, some of those archives are security maintained by those vendors. And that's usually quite a trim set of packages that are absolutely at the core of the operating system. And they are security maintained very diligently for the lifetime, the supported lifetime of that distribution. And for those of you that don't know me, I can speak to this with some authority because before I joined Slim, I was engineering director at Canonical for Ubuntu. So I understand the mechanics of, how this works for the major distributions. Then, of course, you've got the packages then that are maintained by those projects' communities. And traditionally, you can't rely on the security quality of those packages because they're maintained by people who are updating packages for fun and entertainment and hobbying in their spare time. So you can't be sure you have the latest versions and things are necessarily secure. And then this ripples out even further when you get into package repositories such as the Ruby Gems, PyPy, and NPM. That package authority and distribution problem and concept of trust and who do you trust ripples out far and wide. I mean, you simply cannot know who is writing the software that you're shipping into production. It's an impossible task.
Right, and there are so many dimensions to consider when considering the idea of trust, right? It's just a very complicated function. For instance, I read in a report recently, and I think Aisha even published a poll on this yesterday, relating the staggeringly high number of key dependencies, the dependent sort of projects that are highly dependent upon, that have a sole author. This is a dimension of trust that I think is oft overlooked. It's what happens if something happens to that person? This kind of like gets hit by a bus problem. It's a different kind of, it's a different variable in the equation of trust. It's not, I'd like to hope that those people don't skydive or do like base jumping, right? Like it's I'm relying on that package. That author is the sole proprietor and cog who we rely on for updates. What if there's a critical vulnerability? Like that person's the person that needs to patch that for me, right? If they're not around tomorrow or decide to stop working on this thing and let it go dormant, how much technical debt am I holding? How much future technical debt am I holding to go and replace that package? Can I even replace it? So this kind of like the risk puzzle there is really complicated. And we know, just looking at that like single actor problem, we know in security for really critical things, we want dual control. We want more than one actor, right?
Yeah.
We want a consortium of actors because consortiums tend to check each other. And you're unlikely to have like a single malicious actor, act in a rogue fashion because they have checks and balances from their teams. One person, you can't, for instance, you could make a rule that I can't approve my own PR, right? When you have two people, that's easy to do.
Yeah.
When you have three people, that's easier to do. That has a lot of effects on the likelihood of something bad happening based on I'd say an anomalous bad act.
Yeah.
And going back to my knowledge of like critical security systems, I was 25 years building security companies, and we secured some big important things. I won't get into details about them, but they were related to governments and big banks and such like that. And if you think a little bit about like cloak and dagger stuff, CIA, FBI, KGB stuff of old, they love to exploit sole actors.
Yeah.
Because people have a lot of power, and they have and you just have to convince one person to do the wrong thing.
Yeah.
And so I worry about stuff like that with this kind of trust puzzle.
Yeah.
And I don't think we pay enough attention to things like that.
Yeah, I think you touch on some excellent points there. I mean, certainly bus factor is sort of an illustration that rolls off the tongue fairly frequently, but actually what we have seen evidence of many times now is the single developer who's behind a project. They were passionate about something, and then over time their interest wanes, or they're taking it in a new direction, and they don't want to be responsible for that bit of software anymore. So they effectively put it up for auction for somebody to step up and become the new maintainer. And this is where we have seen bad actors take on ownership, maintainership of a piece of software, and then slowly over time introduce malicious code in order to inject that into the supply chain. We touched on that earlier. And the other thing, I was gonna double down on this very point, and you mentioned it, which is if you have single developers or even a few developers, but people pushing code directly to Git without peer review, things can be inserted and not get seen, which is why, having a gatekeeper policy where everything has to come in through a pull request and has to get sign off from at least one other developer, ideally two, to ensure that, what's going into the project is sound.
Yeah, I'll double down on the idea that I think the vast majority of folks producing software are well-intended, hardworking, and committed people, right? I think, one of the challenges they also face that we haven't mentioned is just being able to afford to do this work. This is very generous work for a lot of these people who are building great packages that get used. And yeah, these are good career building things they can do, but a lot of it's a passion play. They do it because they love the problem. They love building software. I think we also have a problem in our free and open source world with getting support for these people to be better and more uniform. And companies take this software and they use it and they build big businesses, and a lot of that doesn't trickle back to the developers who are doing all this good work. It'd be great to find a way to help them more as well. And at Slim, we do Patreon, and we do paybacks for key packages we use. We try to be share the wealth with folks who have been helping us a lot through their work. But I think that's a critical thing as well. Martin, you mentioned like someone loses interest. Well, sometimes the reason for that is they just gotta focus elsewhere to make ends meet, or keep their day gig going strong. So it's not always by choice. It's sometimes by the impingement of reality.
Yeah. And I see Tommy commented to say that they're actually using NixOS. That's a fine choice. I'm a fan of NixOS. I don't use it myself for my main machines or anything, but I'm a big supporter of NixOS. I think it's a fantastic place, particularly if you're producing container images on a regular basis. It's a great place to do that. And you also mentioned, having concerns around the community aspect of a distribution like that and how it's maintained from a security standpoint, and also something like Arch Linux. And there is definitely a difference in the security posture of those community maintained distributions versus those backed by a vendor. That said, when you're looking at fast-moving distributions like Arch and NixOS, you tend to find the security exposure is relatively small if you keep to the packages in the archive, because they move fast and they tend to always ship, the latest upstream releases. And internet law requires me to tell you, I used to be an Arch Linux developer, by the way. So we've talked through a whole bunch of stuff there, and I'd just like to circle back. We talked about know your software, and there are tools to do that. Pete and I, over the last couple of streams, actually have broken out Sift and Gripe from Anchor to do SBOM analysis and also vulnerability analysis. Those are two tools that can help you understand your software, but more importantly, something like Docker Slim or the Slim SaaS platform, where you can get deep insight into your containers after you've optimized your container, because you were making the point, there's a cost upside to being to using the slimming part of the 3S's, because if you eject a bunch of stuff you really don't need, now when insert name of library version 3.2.1 is flagged as being vulnerable, you now know that you're not shipping that stuff into
you don't
production.
have to spend any time figuring out where it is, or worrying about what impact it has, or understanding if there are any exploits. In general, the same is true for just not having that extra package. Means you don't have to consider upgrading it, or the whole lifecycle management of that section of the dependency tree is a no-op for you, because you don't care, even if your developers are using it upstream. So at least in prod you don't have to worry about patching or vulnerabilities cropping up, because it's not there. The best software is the software you didn't ship.
Yeah, indeed. So, I don't think we've got any other questions. Certainly, Tommy's a very passionate NixOS user. So 3 different devices. Tommy's making the point. So I'm going to highlight this because I know we have some sort of Linux enthusiasts that join us here. So Tommy's clearly a fan of NixOS, and I've certainly been advocating on that project's behalf quite a lot recently. If you have even a passing interest in container technologies, you really want to take a look at NixOS. And if you're not prepared to fully commit to NixOS, definitely get familiar with their package manager Nix, which can be used to create container images in a nice reproducible way. And then you can use, tools like Docker Slim and Slim SaaS platform on top to really take yourself to the next level. That stuff works great. Is there anything else you wanted to touch on today, John?
No, I think we've talked about a lot. It's great to see the feedback from the folks on chat. I think all of it's spot on. I think we got a lot of work ahead of us as developers and as people who care about security to make sure that we keep this problem in its place and make a secure place for all of us.
And I can see Tommy saying, "Oh, I'm sorry, I didn't want to take things off topic." We go wherever the conversation goes here. It is a conversation. We don't do presentations here. We like to talk about the things we're passionate about, and we like to riff off the things that people who show up here are also passionate about. We're an interesting mix of developers and thought leaders in the technology space and security space. Linux nerds, there probably isn't a topic, there isn't someone here who can really dive into it and enjoy a deep and meaningful conversation about it. So you're among friends and like-minded people.
Absolutely.
Here.
We love it. I'm actually going to spend a little time tonight in my quiet time digging into NixOS a bit more. You've actually spurred me on.
It's definitely stick it inside a VM and have a play. It's it's a totally different paradigm. It's unlike anything you will have used before in the Linux space. Cool. Yeah, it's great. Awesome. And in fact, if you're not following here, do get followed, because Pete and I are planning to get some of the people from Nix on here to give us like a proper introduction and a deep dive into Nix OS and why it's such a good choice for, contemporary software development.
Cool. Right.
Well, with that, I think I'd just like to say thank you to everyone that turned up. I can see Esme's dropped in here as well. So thanks everyone for stopping by. Thank you for all of your comments and questions. That certainly added a lot of twists and turns to the conversation that we may not have got there without your input. We will be back here streaming on Monday next week and on, get this right, Martin, he looks at his calendar, I think Wednesday next week. I will update the Twitch schedule here. I haven't done it yet because we were just agreeing some of the timetables with our colleagues, but I'll update the Twitch schedule here. So follow us here. I'll update the Twitch schedule. So we're going to definitely stream Monday, Wednesday, maybe Thursday, and we'll do a Q&A in our Discord, which you can find here above my head or in the panels beneath the stream here. Right, well, with that, thanks very much, John. I thoroughly enjoyed that conversation. I hope everyone else here did as well. So thanks for coming, everyone, and we'll see you soon. Bye-bye.
Bye-bye, everyone. Take care.